Hello, everyone. My name is Diego Guerrero. I'm a PhD student on the STEM Lab Monogastric Laboratory. And today I will be presenting our research on the influence of dietary vitamin concentrations and 25-OHT3 in diets for growing finishing pigs. This was presented on the Midwest Annual Meeting on 2025. We all know that vitamins play a crucial role in health and productivity of pigs. While the NRC has set requirements to prevent deficiencies, many diets exceed these levels to optimize the viability of vitamins in feed. This is important due to factors like stability during processing and storage. In 2016, a survey with 70 participants, including companies and producers, found that all utilize higher doses of vitamins, particularly fat-soluble vitamins. Interestingly, higher doses may enhance productive performance and improve pork quality under real-world conditions. For example, in a previous study aimed at determining the effects of increasing vitamin supplementation in weaned-finished pigs, a single vitamin premix was supplemented at various concentrations, ranging from 0, no applications, to 2.5 grams, with 0.5 grams being the closest to the NRC requirements. With the mere addition of the recommended doses, result in a positive response to the average daily gain. Increasing the vitamin levels to beyond the recommendations produce an even greater effect. Regarding vitamin D, which is traditionally recognized for its role in promoting bone metabolism, calcium absorption, and maintaining calcium and phosphate balance, it has a more complex influence on bone health, immune system, and muscle development. However, the biological effects depend on metabolic activation. Vitamin D3 must first be converted into the liver to 25-hydroxyvitamin D3 and subsequently in the kidney to the hormonal form 1,25-hydroxyvitamin D3. Because this hepatic conversion step can be regulatory bottleneck, the dietary inclusion of 25-hydroxycholecalciferol has been proposed as a strategy to enhance vitamin D status and skeletal outcomes in pigs. Although evidence is limited regarding the significant enhancement of productive performance by exceeding recommended levels, studies indicate that incorporating 25-hydroxycholecalciferol in diets of growing finishing pigs can address structural issues such as osteochondrosis. This condition is associated with locomotion challenge, negatively affects growth and development. With this in mind, our study aims to test the hypothesis that high vitamin concentration exceeding NRC requirements alone or in combination with 25-OHT3 can improve both productive performance and pork quality while reducing osteochondrosis effects. We conduct a complete block design with a 2x2 factorial experiment where factors included 2 different doses of the same vitamin premix and the addition or absence of 15 micrograms of 25-OHT3. To show you the comparison of vitamin premix that we use in the experiment, here is the chart or the graph where you can see in orange the NRC requirements and dark blue the premix level of 0.125 kilograms per ton, and in light blue the premix at 0.5 kilograms per ton. So you can see that in some vitamins it was over 10 times per vitamin, like for vitamin D or vitamin E. We conduct this experiment in an experimental farm located at Querétaro, Mexico. We studied 440 growing finishing pigs with an initial body weight of 25.5 over 3 groups housed in 44 pens, 10 pigs per pen, with a random assignment by weight, sex, and litter. The feeding program consists in 4 phases lasting 21 days each, using conventional ingredients common in the Mexican swine industry to meet the NRC requirements. We measure various parameters, including average daily gain, average daily feed intake, gain to feed ratio, poor quality, and histopathological evaluation of osteochondrosis lesions. Our statistical analysis was conducted as a randomized complete block design. All the data was analyzed using SAS, utilizing procedures such as PROC-univariate, PROC-means, and PROC-GLM. For histopathological evaluations, we use a non-parametrical method known as Kruskal-Wallis. For the osteochondrosis evaluation, we took 4 different joints, known as glenohumeral, femoral patellar, metacarpophalangeal, and metatarsophalangeal. From these, we took samples of each bone and made a sagittal cut, and then we made another cut to take a sample where we can see the articular cartilage and the physis. This sample, we stained them with H&E and scoring the injury levels while keeping evaluation blinded to the treatments. In this scale, you can observe the range that we use to evaluate each lesion related to osteochondrosis, going from normal, that was 0%, to very severe, above 50% of the tissue was injured. Moving on to the results. First, I'm going to introduce you the graphic. In the x-axis, you will find the different variables that we measure. In light blue, you can see the vitamin premix with a low concentration with no 25-OHT3. In orange, you will find the low vitamin premix with the addition of 25-OHT3. In dark blue, it will be the high doses of vitamin premix with no addition of 25-OHT3, and the dark orange will be the high doses of vitamin premix with the addition of 25-OHT3. Interestingly, we found no significant difference in overall growth performance due to the increase of vitamin concentration or the addition of 25-OHT3. For poor quality, evaluations showed that increasing vitamin levels did not significantly affect pH or overall color. Additionally, shear force values, which indicate tenderness, decreased with elevated concentration of vitamins and the addition of 25-OHT3. One critical finding was that higher vitamin concentrations and 25-OHT3 significantly reduced the severity of osteochondrosis lesions in pigs. This suggests a protective role of these nutrients that play in joint health, especially during growth phases when bone development is essential. Remember that we analyze this data with Kruskal-Wallis using a Wilcoxon multiple comparisons because it was a non-parametrical variable. In summary, while increasing vitamin concentrations above the NRC requirements and including 25-OHT3 did not significantly enhance growth performance, they improved meat quality parameters and reduced the incidence of osteochondrosis. This research indicates that focusing on these nutritional strategies could enhance swine production and welfare. I would like to thank to my co-authors and our institutions, al Instituto Nacional de Investigaciones Forestales Agrícolas y Pecuarias, to the Universidad Nacional Autónoma de México, and the University of Illinois Urbana-Champaign, and also to the STEM lab that helped me to present this work at the Midwest. If you want to know more about us or our research, I invite you to visit our website, STEM Monogastric. Thank you very much for listening,